Hello, this is Mr. Win, and this video is about similar triangles. So in the last video, we had similar figures, no matter how many sides. This video focuses on similar triangles. Pretty much everything's the same, and to be similar, all three angles must be equal, and all three sides must be proportionate. Triangles will just try to mix or blend themselves with each other, and triangles can also be similar in one other scenario, that is two proportional sides with a congruent included angle. It's kind of like the SAS. So, are these two triangles similar? If so, write the congruence statement. So first, we see two triangles with some angles. You should be able to do triangle sum and find the last angle. So it's at 57 plus 48 plus whatever missing on x is 180. Combine like terms, that is 105 plus x is 180. Subtract 105, x is 75. So we found all three angles here. Let's see if the other triangle has the same angles. I'm going to triangle sum. I'll use a different color. There you go. All right. Triangle sum. Angle plus angle plus angle. Let's call it x again. Here's 180. Combine like terms, 132. Subtract, I get 48. Are those three angles the same? 48, 57, 75, 48, 57, 75. Yes, they are. So, yes, they're similar. Write the congruence statement, or similarity statement. Triangle, it doesn't matter the order. First one is called JKL. I like that. JKL is similar. Now the order matters. J was 48 degrees, so Q is 48 degrees. That's good. K is 75. P is 75. Then L is 57. M is 57. There you go. Alright, the bottom problem. Are these triangles similar? So are the congruence statement. 90 degrees, 44. If you do triangle sum, hopefully you know that makes 46. I know because 46 and 44 make 90. And 99 minus 180. This makes 43. Are they the same? No, so these are not similar. Alright, here's the next one. Are these two triangles similar? So write the congruence similarity statement. Alright, hidden givens. We have vertical angles. Alright, and yes, we have parallel lines. If you have parallel lines, you know you have alternate interior angles that are equal. So we have a transversal, so this angle is equal to this angle. And actually, we can think about this. If two triangles have two of the same angles, will the third angle be the same? For example, if one angle is 50 and one angle is 60, for one triangle, the other triangle has one angle 50 and one angle 60, does that mean the third angle is the same? The answer is yes. So for triangles, we call that AA similarity, but we also call it AAA similarity if you want. I mean, if you know two of the angles, you need triangle sum, get the third angle, they'll be matching. So these are similar. Write the similarity statement. Well, let's do triangle. I'll say yes. Triangle is called a XSR. Why not? XSR. Similar. X had 2 marks, so T has 2 marks. What else? S has 1 mark, so S has 1 mark. R has 3 marks, W has 3 marks. You can call this by AA, parentheses A, similarity. That's only a postulate. Alright, but just use common sense there. Down here, those two triangles similar, so write the similarity statement. Alright, they are touching. This is interesting. Instead of reflexive side, it's reflexive angle. Angle L is reflexive itself. Then we can see this. This angle right here is corresponding to this because we have two parallel lines and a transversal. Corresponding angles are congruent. These are also corresponding. So yes, again, these are similar. Let's see. Let's call it a JPQ. Similar. Sorry, L. Alright, L has 1, L has 1, P has 2, J has 2, Q has 3, K has 3. Again, by A similarity. Alright, here's the next one. Are these two triangles similar? They do have vertical angles, but that's not enough. So I'll check the sides. We'll see if the sides are proportional. So we'll do the biggest side over biggest side. So let's see. I'm gonna erase this. I'm gonna try to make the pair. So the biggest number must go to the biggest number. This 20 has to go with 8 no matter what. This middle number 15 must go to the middle number 6 no matter what. And the smallest number has to go to the smallest number. All right, let's check the scale factors for each. All right, we'll do a 15 over 6. That reduces into, let's see, divide by 3, divide 3. That makes 5 over 2. All right, the next one, let's do green. It was 20 for the bottom, 8 for the top. Divide by 2, that makes 10 over 4. Divide 2 again, that makes 5 over 2. Oh, they're matching, that's good. We'll try one more. Blue, 12.5 over 5. I'm going to double that to get rid of the decimal. So that's 25 over 10. I'm going to divide 5. I get 5 over 2. Look, all three are matching. 5 over 2, 5 over 2, 5 over 2. So those are similar. So yes, they're similar. I can write the congruent similar statement. Triangle. Let's do top P. PQR. Why not? Alright, now it matters. Let's see. I'm going to do this. P to Q is red. Then Q to R is blue. I say a square to triangle. So on the bottom, square to triangle. Square to triangle. I have to go left. So STR. There you go. This is by SSS similarity. We have 3, all sides are proportional, then yes, they're similar. Down here, are these two similar? This one, this is a special case. This is the SAS one. So angle A is equal to itself. If I split this triangle into 2 triangles, it might make more sense. So we have this angle, we have this 8, we have this 10. This is angle A right here. If I do the bigger one, it's not drawn in scale, that's okay. 8 plus 4 is 12. 10 plus 5 is 15. All right, I'm checking, are these sides proportional? Is 8 over 12, what is that? Divided by 2, that's 4 over 6. Divided by 2 again, that's 2 over 3. Because this make a pair right here. I'm going to try this other pair. 10 over 15. I divide by 5, that's 2 over 3. They're matching. Since 2 sides are proportional, 2 pairs of sides are proportional, and the angle between them, the included angle is congruent. This is yes. They are. Triangle. And I'm going to put these letters here. So this is A, this is E, this is F. On the bottom, this is A, C, B. This will make it easier for me to write. All right, so if I say AEF, that's similar. Triangle. ACB. By this one's SAS similarity. All right, what else we got? All right, once your triangles are similar, then you can find the corresponding parts or pairs. Then you pick 2 and solve for missing things like before. So the following triangles are similar. Find X. So if we look at the angles, this is technically an angle similarity, but they're similar. X obviously goes with this 12, and then the 6 goes with 4. All right, so I like doing pairs, corresponding parts, instead of a triangle by triangle. So I'm gonna do circle pair over circle pair equals square pair over square pair. So I'll do top triangle. So top triangle circle, bottom triangle circle equals top triangle square over bottom triangle square. Here we solve this. Multiply both sides. I'll do it by 12. So this is X equals 12 times 4 is 48 over 6. I could reduce and be finished, but I'm just gonna do this just so y'all get used to getting rid of fractions. That's 6x equals 48. Then divide by 6. Final answer. X equals 8. All right, here's the next one. Triangle similar. Find X. All right, I would split this triangle in 2. Might make it easier. So we have QRS. This is 12, and this is X. So we have a bigger triangle. QPT. This is 16, and this is all 20. All right, hopefully now you can see X and this make a pair. This and this make a pair. Again, circle over circle equals square over square. And like if you wanted to, you could do circle over square equals circle over square. Your choice. I like doing this more though. Solve each. This times by 16. So this is 16x over 20 equals 12. That's times by 20. So 16x equals 240. Divide by 16. That is 15. It says find x. We found it. Done. So we found 15 here. If you want this other one, that's 5, because 15 5 makes 20. Alright, still similar. Be careful. They're trying to trick you a little bit. Okay, here's the angle. This is 90. And this angle matches this angle. Alright, so what goes with what? This is the cross from the 90. This is the cross from the 90, so that's my pair. Anything else? This work? Actually, this will work. I'll tell you why later. Alright, so circle over circle equals square over square. We're going to solve this. Ooh, these are big numbers. That's okay. So they don't cancel out. So that's 96x. 96, 192. Over 40 equals x plus 6. Times 40 times 40. 96x minus 192. 40x plus 240. We're going to solve for x. Move x to one side. I'm going to subtract 40x. That makes this 56x. Add 192. 3, 4, 32. Actually, upon second thought, this problem needs to go not teach all yet. I'm going to use Pythagorean theorem to find this side because I don't have the correct pairing. But that's okay. We'll skip this for now. We'll come back to it later. This one, they're similar. Find x. This one's easy. I can find the pairs. Let's see. This is between the 1 and 2 angle marks. Between the 1 and 2 angle marks. And then this is across the 1 angle mark. Across the 1 angle mark. Alright, so I can do a circle over circle equals square over square. Multiply. This one we can do 8, so that's 32x plus 8 is 56 over 12. 6x minus 2. Multiply 12s. That's 32x plus 56. 12 times 6, 60, 72x minus 24. Get x to one side by subtracting 32x. That makes 40x. That's 56. Add 24. That makes this 80 equals 40x. Divide by 40. 2 equals x. Questions find x. Done. Alright, last slide. One of the best things triangle similarity can do is allow us to take indirect measurements. Knowing a person's height and shadow length can, and another object's height or shadow length can help us find whatever's missing. So a girl 5 feet tall. Let's draw this. She's 5 feet. Cast a 3-foot shadow. That's what is right angle. Here's that triangle. And there's a tree, a tall tree, cast a 60-foot shadow. Right angle, and we're trying to find this. How tall is this tree? These are always proportional. They're similar. This height goes to height, shadow goes to shadow. So let's solve that. So circle over circle equals square over square. Multiply both sides by, I guess, x first. So that's 5 equals 3x over 60. Multiply both sides by 60. So ugly 3. Let me write that. Alright, that makes it 300 equals 3x. Divide both sides by 3. 100 equals x. That is feet. So the tree is 100 feet tall. Alright, that's for the video. Hope you enjoyed it. Make sure you ask any questions. Thanks for watching. See you soon. Bye.